Okay, welcome today. We are going to be working on rewriting formulas and equations. And so when we rewrite a formula, first let's define a few things. Let's talk a little bit about a formula. A formula is essentially an equation that contains two or more variables. An equation that contains two or more variables. We have lots of examples of formulas, like for example, the formula you use to find the area of a circle is pi times the radius squared. The area that you use to find the area of a square, for example, is side squared. The area of a regular polygon is 1/2 the apothem times perimeter. So those are various formulas that we've been using probably a little bit in our geometry courses, talking a little bit about formulas. And again, it's an equation that contains two or more variables, two or more unknown quantities. All right. To solve for a variable essentially says to isolate a variable, a particular variable, on one side of the equals. Okay, so on one side of the equals, you want to try to isolate. And again, think about the word isolate. That means all by yourself. So we want to try to get that variable all by itself on one side of the equation. All right. So rewriting a formula with two variables, let's kind of talk a little bit about a few examples here. So when we're trying to solve a formula for a specific variable, basically it says this. We're trying to solve the formula circumference equals 2 pi r for r, which again, this happens to be the formula for circumference. We're trying to solve for r. We're trying to get that radius all by itself. So it says, then find the radius of a circle with a circumference of 26 meters. We're going to deal with that second statement in just a few minutes. But the first thing is we need to write this so that it says r equals. We're trying to isolate r. So right now, r is being multiplied by 2 and multiplied by pi, and so we're just going to undo both of those by dividing both sides by 2 pi. And so the radius is equal to whatever circumference divided by 2 pi is. All right? So again, divide both sides by 2 pi. So in the original formula, your formula now is circumference divided by 2 pi is equal to the radius. And now we're going to go ahead and we're going to plug in that second piece of information. It says find the radius of a circle with a circumference of 26 meters. So 26 divided by 2 pi. Now, please keep in mind that pi is not a variable. Okay, it's not an unknown quantity. We know that pi is 3.14, 159, etc., etc. It is an irrational number that is non-repeating and non-terminating. All right, and so we have that value, and it's stored into our calculator for us already. All right, so again, we're going to substitute 26 in for circumference and simplify. And so now we need to go over to our graphing calculator to do that. All right, and so what we're going to do then is we're going to say, look, this is 26 divided by, and if you type 2 pi in your calculator and you plug that in, you're going to get a radius of 40 meters. Now, this is an incorrect answer, and here's why. Your calculator does order of operations in the proper order. It's going to do division and then multiplication as it appears from left to right. All right, the formula that we've solved says take the circumference and divide it by the quantity 2 pi. So we need to know what 2 pi is so that I can divide 26 by it. Okay, this calculation is not going to be correct. What we need to do instead is we need to say this is 26 divided by and use 2 pi in parentheses. We've got to use those parentheses on your calculator. So that says take the quotient, or take the product of 2 pi, and then go ahead and do the quotient. So you get a radius of approximately 4.13, roughly 4 meters. All right? So as I go back over here to this, this is approximately 4 meters. All right? So go ahead and pause your video. You're solving, the next one you're solving for C. That means we need to get C all by itself. Pause your video, try this checkpoint problem, and we'll be right back to show you the solution, okay? All right, so if you've taken time to pause your video, then you see that this may or may not have been a difficult example. This is going to run out of space, so I'm going to put it over here. F is equal to 9/5 times C plus 32, and we're solving for C. So my tip for you is to circle the variable you're solving for and say, look, I got to get that by itself. So C is being multiplied by 9/5, and it's also, we're adding 32. So when we solve, we always work backwards. So we're going to get rid of the addition first. So this is F minus 32 is equal to 9/5 C. All right? So what we want to do then is we want to eliminate the multiplication of 9/5. We talked about this in our previous videos. We don't want to divide by 9/5. We don't divide by fractions. Instead, we multiply by the reciprocal. So we're going to multiply this side by 5/9, which is going to effectively eliminate the 9/5 and get C all by itself. Be careful though, because you have to multiply the entire left side of this equation by 5/9. All right? And if you want to, you can go ahead and distribute it, but when you multiply 5/9 times -32, take my word for it, you're going to get something kind of ugly. So we're just going to leave it as 5/9 times f minus 32. I'm going to put that as the coefficient instead of after the parentheses. It means the same thing. And so you have 5/9 times the quantity f minus 32. So from there it says the Celsius temperature is equal to 5/9 times the Fahrenheit temperature, which is 85 minus 32. Well, 85 minus 32, that happens to come out to 53. And then 5/9 of 53 comes out to approximately 29.4 degrees Celsius. All right? And so 29.4 degrees Celsius is exactly 85 degrees Fahrenheit. Okay? All right, so our next example, we're going to look at an equation with more than one variable, or rather 3 variables. All right, the previous ones have only had 2 variables, and we've solved for one of the 2. Now we have 3 variables, and it doesn't matter that these are unknown quantities. Again, we're solving this for L. Apologize. We're solving this for the length, so we want to get the length all by itself. So the first thing we're going to do is we're just going to write the formula. We're trying to get L all by itself, so we're going to get rid of multiplying that by dividing both sides by W. So you get A divided by W is equal to the length. So what we're going to do now is we're going to say, look, my formula is now rewritten as A divided by W. Okay, we already have it's A over W. And we're going to substitute in 187 square feet for the area, and we're going to substitute in 11 feet for the width. And so this becomes 187 divided by 11. 187 divided by 11 comes out to, conveniently, exactly 17 feet. All right, and so the length of the rectangle has to be 17 feet. Okay, 2 checkpoint problems for you guys to try. Again, pause your video, give them a shot, and then we'll be right back to show you the solutions. Okay, so if you've taken the time to try these 2 examples, you will find out that the first one you should have gotten 7 meters and the second 4.5 hours. Now, how do we actually obtain those 2 answers? In number 2, we're going to start this one over here. We're trying to solve for the width. So that means I'm trying to get width by itself. So I get perimeter equals 2 times the length plus 2 times the width. I'm going to minus 2 length from both sides. Okay, and so I get P minus twice the length is equal to twice the width. And again, if you're just going to deal with this as variables, again, we've got to get rid of additions before we can get rid of multiplications. So we get rid of the quantity 2L by subtracting it from both sides. So now we're going to divide both sides by 2, and you get W is equal to, now you can leave it like this. This really isn't truly simplified. Understanding that P minus 2L over 2 is the same thing as P over 2 minus 2L over 2. Again, because each of them is separately over a 2. All right? So this becomes P over 2. I'm sorry, W equals, I like the variable first. W equals P divided by 2 minus, and then 2 over 2 is just going to be 1, and so minus 1 times the length, or L. So we're going to go ahead and plug in the information they gave us. 32 meters is the perimeter. The length is 9 feet, so we're going to plug that stuff in. 32 divided by 2 minus 9. This is 16 minus 9, because again, 32 divided by 2 is 16. 16 minus 9 is 7. All right. The second example says the distance formula, distance equals rate times time. We're solving this for time, so we're going to circle the t. We've got to get rid of multiplying by the rate, so divide both sides by the rate. So the time will be equal to the distance divided by the rate. All right. So they give us a rate of 30 miles per hour. They give us a distance of 135 miles, so we're going to say the time is equal to the distance, 135 miles, divided by the rate, which is 30 miles per hour. And 135 divided by 30 comes out to 4.5. Again, units were in miles per hour and miles, and so your units for the time are going to be in hours. All right, not seconds or minutes or anything like that. Since you're dealing with a rate that's in hours, miles per hour, then your answer is going to be in hours. All right? So, the home stretch then is taking a look at solving an equation, what we call a linear equation. And this linear equation is said to be in standard form, something you probably looked at in Algebra 1B. So it's been a little while for many of you. But we're trying to solve this equation for y. That means I want to try to get this y all by itself. All right? So you have 5x minus 4y. We need to get rid of this positive 5x from both sides. Some people might confuse this subtraction sign as this applies to the 5x, but the 5x is a positive 5x. It's the 4y that's negative. All right? So in dealing with that, then again, we're trying to focus and solve for that y. So the first thing we're going to do is we're going to subtract the 5x from both sides. And I'm going to try to squeeze it in down here. We're going to minus 5x and minus 5x. So these cancel out. On the left side, all I have left is the negative 4y. On the other side, it's 9 minus 5x. All right? So then we're going to divide both sides by negative 4. So we're going to divide this whole side by negative 4. And just like on the previous problem, remember I said that it's this over negative 4 and this over negative 4. This becomes 9 divided by negative 4, which is negative 9/4. And then the second part of this is negative 5 over negative 4, which becomes positive. And then 5 over 4, we're just going to write it as 5/4 x. All right, now perfectly acceptable as well as 5x over 4. That would be fine. But 5x divided by 4 is the same thing as 5 divided by 4, then times x. Order of operations should tell you that. So then it says, all right, find y when x equals negative 3. Well, our equation is written in terms of x, so all I have to do is plug things in. Y equals negative 9/4 plus 5/4 times negative 3. Now, remember, this is negative 3 over 1. I got to go back a ways. To multiply fractions, 5/4 times negative 3 over 1. Remember, we multiply fractions, we just multiply tops and bottoms. So this is negative 9/4, and positive 5/4 times negative 3 becomes negative 15/4. Negative 9 minus 15 more. Okay. Negative 9 minus 15 more becomes negative 24. Because again, common denominator, you just have to add the tops. Negative 9 plus negative 15 becomes negative 24 over 4. And 24 divided by 4 is 6. Negative divided by a positive is negative. And so y is equal to negative 6. A lot to do with signs in that one. Be very careful with that, especially when you start dividing negative by a negative. We have to change this sign here. I mean, there's a lot in there. So definitely a lot of room for error, but something you should be able to do. Okay? All right, and our final example for today is solving something that's nonlinear. This is a nonlinear equation because it has the product of x and y. We're trying to solve this thing for y. Now, we have to think of this idea of factoring, and not factoring like, you know, quadratics, like we're trying to find two numbers that multiply to make the center number kind of. That's not the factoring we're talking about. We're talking about factoring out the greatest common monomial factor. So when I think about factoring, I think about this idea of I know this is not a word, so don't tell your English teacher. Okay, factoring is like undistributing. It's like taking it back out. All right, so if I multiplied something, I distributed it, how could I undistribute that? So you'll notice that both of these have a factor of y in them. So effectively what I'm going to do is I'm going to factor a y out of both of them and put the y over here on the side and leave this as 8 plus x. Now you might wonder where I got that, but guys, if you just check this, y times 8 is 8y, and y times x is y times x, or x times y as they have it here. All right? Okay, so our next order of business then is, again, we're trying to isolate this y. We're trying to get it by itself. So we need to get rid of multiplying by a plus x. All right, well, it makes sense then. We would just divide both sides by a plus x. And so you get 10 divided by 8 plus x. Not the most exciting equation in the world, but it's 8 plus what x is. Now we're going to actually substitute it in. So our x is negative 6. And 8 plus negative 6 becomes negative 2. And 10 divided by negative 2 comes out to 5. Whoops. I'm sorry. 8 plus negative 6 is positive 2. Glad we caught that. And 10 divided by 2 is 5. All right, so last two checkpoint problems. Go ahead and pause your video, try them, and then come on back and let's check on our solutions, okay? Number 4 asks you to solve for y, so we got to subtract 6x from both sides. 2y equals, now you can write this as 14 take away 6x. Later on, we're going to start calling this a linear equation. We're going to write the x first, so we might as well get in the habit of doing that. Let's just put the negative 6x first. And from there, we're going to divide both sides by 2. And like we said before, this is two separate fractions. So this is negative 6x over 2, which becomes negative 3x. And 14 divided by 2, which is 7. And so y equals negative 3 plus 7. Negative 3x plus 7. So now we're going to go ahead and substitute our value of x into here. This becomes y equals negative 3 times 4 plus 7. Negative 3 times positive 4 is negative 12. Negative 12 plus 7 is 5. Negative 5, excuse me, negative 5. And then finally, for the last example here, this is one of those where we have to undistribute or factor a y out of both terms. So in this case, then, what you're going to do is you're going to say, we're going to have 3 minus 4x, and we're going to just undistribute or take out a y. If I take a y out of 3y, that leaves 3. If I take a y out of negative 4x, it leaves negative 4x. From there, we're going to divide both sides by negative 3 minus 4x. And again, it's not the cleanest formula in the world, but y equals 26 over 3 minus 4x. From there, we're going to go ahead and substitute our value of x. Y equals 26 divided by 3 minus 4 times 4, because again, x is equal to 4. So we're going to plug that in. So this is 26 divided by, and then 4 times 4 is 16. 3 take away 16. 3 take away 16 is negative 13, so 26 divided by negative 13, and so 26 divided by negative 13 is negative 2. All right? So hopefully you followed the video well, taking good notes, and we'll talk about some of your questions first thing tomorrow.